Inventor Roy Rosser has invented a novel, magnetically sprung overrunning clutch. This is a device that can, for instance, be used as a freewheel hub in a bicycle. A US provisional patent application has been filed and is currently pending. Roy's novel freewheel device is simple, has a very rapid uptake or engagement, and has low overrunning friction. This is a proof of concept prototype in action. Notice the rapid pickup or engagement and the low overrunning friction. This is a look inside the mechanism in the form of a drawing from the pending patent application. And here is the mechanism shown as a three-dimensional computer rendering. The blue element attaches to the driven shaft, while the pink element is attached to the driving shaft. The yellow elements are the magnetically sprung pawls that fit between the blue inner driven member and the pink outer driving element. When the pink driving element is moved in a clockwise direction with respect to the inner blue element, the yellow magnetically sprung pawls become wedged, locking the driving element to the driven element. When the driving element is moved in a counterclockwise direction, the pawls are released, the elements unlock, and the driving shaft overruns or freewheels. The square holes are where the magnets and the ferromagnetic materials that attract the magnets are situated. Here are actual 3D printed parts. For cost and convenience, the parts have been 3D printed in high-density plastic. They could, however, have been machined or made from any non-magnetic material, such as aluminum, titanium, or any one of the non-magnetic austenitic stainless steels. That is, any of the 188 or 300 series of stainless steels that contain both chromium and nickel. These are the stainless steels that are most widely used in machine parts because of their superior wear, strength, and corrosion resistance character. In these prototype parts, the pawls have been fitted with commercially available neodymium rare earth magnets. The magnets actually used cost 27 cents each from a retail supplier. The driven elements have ferritic stainless steel inserts. This is one of the stainless steels that is ferromagnetic. This is the material that the magnets are attracted to or sprung from. The 400 series stainless steel keys used in the prototypes cost 80 cents each, also from a retail supplier. As you can see, the pawls are easily placed on the driven shaft. Because the springing is magnetic, it is strongest when the pawls are in a locked or engaged position, and weakest when they are drawn back in the overrunning position. This helps strengthen the engagement while reducing friction during the overrunning. This is in direct contrast to conventionally sprung pawls, which are weakest when engaged and offer most resistance, and therefore unwanted friction, when overrunning. Magnetic springing also automatically positions and aligns the pawls correctly, eliminating the need for additional elements to keep them in their proper orientation. This simplifies the design, allows looser tolerances on individual parts, and reduces both material and assembly costs. Here, once again, is the proof of concept prototype, assembled and operating. So that is it. Roy Rosser's novel, patent-pending, magnetically sprung overrunning clutch. A device that, because of its cost and performance advantages, may become used as an improved freewheel hub in some, or maybe all, of the 110 million new bicycles sold worldwide every year.